Hello everyone. Hope you all are doing well and safe during the pandemic. Today, on behalf of our team, I am glad to present the outcome of one of our recent works titled Multimodal Deep Learning Framework for Sentiment Analysis from Text, Image, Web Data. I will be following this outline for the next 20 minutes or so. Let's start with a little bit of background about our study. Humans generally express their opinions or sentiments through a variety of media on the web, such as image, voice, and text. The process of recognizing sentiments from such media is called the sentiment analysis, which is also known as opinion mining. It is basically the field of study to understand what others think about something. Currently, we work on a comprehensive, in-depth analysis of sentiments considering different model information available in the web. In recent years, the sentiment analysis has been known as an active area of research. Further, it has been significant in many fields and applications. Apart from the traditional usages of sentiment analysis applications, nowadays there are a variety of new problems require sentiment analysis prominently. For example, in the health sector, healthcare professionals use automatic sentiment analysis tools to extract the sentiments during the medical interventions. In particular, they need an automatic way to analyze the negative sentiments of the patient during the medical checkup in order to provide the appropriate treatment. Another example, education providers these days need to have automated sentiment analyzing tool to assist with the classroom teaching environments, where understanding students' feeling is very important to scale the effectiveness of the teaching process. Next, in a crowded area, manually analyzing the sentiment changes and intents is a tedious and time consuming task. In such situations, timely identification of the intent of an individual in the scene is very important so that appropriate alerts can be issued for further analysis by the surveillance officer or the person who is responsible for that. The emergence of artificial intelligence and social robots also play a vital role in the human and machine interactions. In order to improve such interactions with the machine, the robot need to recognize the sentiments and respond appropriately. In other words, they need to become emotionally sentient agents. Next, we look into some critical limitations of existing sentiment analysis approaches. The majority of the existing works have focused on unimodal based sentiment analysis. Among them, a number of works have exclusively utilized the text or image to perform sentiment analysis. Some of the latest studies have explored the potential use of speech in the sentiment analysis as well. However, the most common problem of single model based approaches is the limited availability of the sufficient meaningful sentiment related features. Thus, unimodal sentiment analysis approaches often achieved low recognition rates. On the other hand, multimodal sentiment analysis approaches have recently been proposed as a prominent solution for this problem. In particular, recently some pertinent sentiment analysis approaches using combined features of image and text have shown promising results. However, they struggle to effectively learn the association between high level human semantics given by textual features and the corresponding low level visual features. Moreover, as stated before, the multimodal informativeness and correlated associations of the web data provide opportunities for multimodal sentiment analysis. These are some of the example text and their sentiments obtained by a text-based sentiment analysis approach. Next, I will elaborate about the proposed method in detail. Understanding people's sentiment from data published on the web presents a significant research problem and has a variety of applications, such as learning the context, prediction of election results, and opinion about any incident. Another important motivation is to get use of image text cues with their relationships to recognize the sentiments. As you can see, this figure illustrates an image with negative sentiment where the potential interrelationships between some of the words and visual regions are highlighted. However, only the words such as depressed man and looking down are considered high attention word segments since they contribute toward the negative sentiment. The correlations between these high attention words and associated salient visual regions are considered as pertinent interrelationships. So, in addition to discriminative features extracted from images and text, it is also reasonable to learn these pertinent interrelationships to improve the sentiment estimation from image text data. To elaborate it clearly, there are words from W0 to WN as indicated here, having pertinent relationship with regions R0 to Rn in the image. Let's talk about the novelty and contributions. The first contribution of this work is the pertinent interrelationships between the high attention words and salient image regions are analyzed and incorporated as an additional feature in estimating sentiments from text image data. Also, a carefully crafted fusion mechanism is proposed in learning these interrelationships. The second contribution of this work is a novel, deep, multimodal sentiment analysis framework is proposed that can effectively estimate the sentiments from image and text data. The VGG16 and Very Deep CNN are used to extract the discriminative features individually from images and text, respectively. The third contribution of this work is the proposed scheme is extensively evaluated on a newly constructed text image dataset consists of positive, negative, and neutral sentiment samples. And also, the experimental results demonstrate the applicability of our multimodal sentiment analysis scheme in classifying various sentiment classes. We perform multiple steps to select the high attention words and salient image regions. As the first step, a filter operation is performed to remove the words or word segments not belonging to sentiment class of the entire text. Here, the sentiment class of each eliminated word or word segment is not equal to sentiment class of the overall sentence. As you can see here, the sentiment class of the sentence is negative. So, the individual words or word segments that belong to negative sentiment class will only be selected. Note that the maximum length of any segment or any word segment is set to 2 words. So any existing state-of-the-art sentiment analysis tool can be used to determine the sentiment class of the word or word segments individually with their confident values. Consider that there are n such words or word segments. The resultant vector W all can be expressed like this, where WI-CI pair indicates the ith word and WI and its confident value Ci. Subsequently, the corresponding image regions for all the words and word segments that contribute positively towards the sentiment class of the entire text are defined. At this step, the words or word segments that carry text-free private information, where it is hard to acquire the sentiment regions from the image, are first eliminated from the selection process. The R, the region vector R rev can be represented as given here, where Ri is the region in an image associated with ith word or word segment in the revised word vector W rev. From the rest of the words or word segments, one with the highest confident value is now picked as the high attention word or word segment. Finally, the image region corresponding to the high attention word which is selected from the region vector as the salient visual region. The equations are given as here. The next important aspect is learning the interrelationships between the high attention words and the corresponding image regions. Inspired by the recent successes of the intermediate feature fusion schemes, an association module is constructed with an intermediate feature fusion to effectively learn the interrelationships between textual and visual features. Two pre-trained deep feature extractors are used here. The intermediate feature aggregation is performed using the mean operation. The equations are as given here. When it comes to the summary of the proposed framework, basically there are three streams including two unimodal streams and one association module. Unimodal streams are visual feature stream and textual feature stream. Multimodal stream is the association feature stream. A pre-trained VGG16 used as the visual feature extractor, meanwhile the VDCNN used as the textual feature extractor. And intermediate fusion and a late fusion are used here. This is the overall architecture of our proposed framework. Next, I will discuss a newly constructed multimodal sentiment dataset and a set of experiments and results to analyze the proposed sentiment analysis framework. The proposed multimodal based sentiment analysis framework is evaluated on a dataset consisting of social images with Creative Commons copyright collected from Flickr, Getty, and Google. As mentioned before, there are three sentiment classes available in our dataset, namely negative, neutral, and positive. In order to define each sentiment class, a range of sentiment related key vocabularies is first collected. Then, each of these key vocabularies is grouped based on its proximity to one of the sentiment classes using dictionaries. These key values are used as keywords to search for social images. In constructing the description of the downloaded images, a combination of tags, comments, and post text is utilized alongside the visual information of the image. These are some of the examples from the constructed dataset. I will now present and discuss the results obtained on the newly constructed dataset. 6 different configurations were trained and tested in order to evaluate the proposed multimodal based sentiment analysis framework. The first and second configurations only consider the visual features, where the first one takes only the VFS. In contrast, the second one uses the salient region input as an additional feature. Similarly, third and fourth configurations consider TFS only and TFS with high attention word respectively. In the fifth configuration, the VFS and TFS are combined to estimate the sentiment. The final configuration is the complete proposed framework. The confusion matrices for the obtained class-wise sentiment analysis results for each configuration of the proposed framework are presented in this figure. As can be seen from the results, the proposed framework consistently performed well for positive sentiment class in comparison to other sentiment classes. For example, the classification accuracy for the positive class obtained by our final model is 88%, which is obviously greater than the accuracy obtained for negative and neutral sentiment classes. This may be due to majority of the samples in the positive sentiment class have better discriminative features both visually and textually. Further, the overall classification accuracy and F1 score are reported in this table. By observing the results, one can see that the proposed multimodal based sentiment analysis framework comprehensively outperformed other variations with a classification accuracy of 82.81 and F1 score of 82.75. More importantly, the higher F1 scores reported demonstrate that the proposed framework is capable of handling unbalanced data. Also, the significance of the intermediate fusion scheme applied in AFS is also analyzed. To perform this, an additional variant of the proposed framework without the intermediate fusion is constructed. In this case, a straightforward late fusion is employed to combine all 4 features. This figure illustrates the feature embeddings obtained before and after adding the intermediate fusion. It is evident that adding an intermediate fusion significantly reduces the intra-class variations, which can potentially increase the classification accuracy. Let's conclude our presentation. We proposed a multimodal based sentiment analysis framework that effectively estimates the sentiments from text, image, web data. This is the first one to learn the pertinent interrelationships between high attention words and salient image regions. We experimented on a newly constructed text image sentiment dataset. We obtain a better classification accuracy and F1 score. Hence, the proposed framework is capable of accurately recognizing the sentiment classes. Next, the references. These are some of the references used in our work. For any further questions, please reach me at this email ID. Thank you.